Now, if you take a look at the Petya malware that we talked about earlier, and you also look at the different security technology built into Windows 10, and we overlay that, you'll see that we actually could have protected ourselves against Petya had Windows 10 been in the environment with these different features enabled. So as you see here, from actually blocking that malicious software from being downloaded in the first place, could have been protected by device guard, secure boot to prevent Petya from changing the master boot record, being able to exploit SMB could have been done by kernel hardening built into Windows 10. Credential theft could have been prevented through credential guard. Encrypting of the actual files on the computer could have been prevented with controlled folder access in Windows. And then running that code could have been prevented from device guard. So as you see, this actually could have helped to even prevent Petya from ever running an environment in the first place.
But I did want to show you DocuSign and how they have SCIM provisioning set up. So this is an enterprise application. We have the ability to choose the type of single sign-on and the type of provisioning that happens. And in this mode, we actually have automatic provisioning happen. So users are removed from the directory or added to the DocuSign directory whenever those applications, whenever the user is assigned a group. So for here, we just have to go hit add user, and the user will be provisioned within the hour.
So what we have built into Office 365 is what we call the attack simulator. So from here, I'm going to click on this, and I can do multiple things in here. I can create a spear phishing attack. I can do a brute force password attack and a password spray attack. I'm going to focus here for the next few minutes just on the spear phishing attack, right? These are simulations, right? And I can really track and see, hey, how much of a problem do I have with my user environment not being educated? You know, in other words, I'm going to send this out and try to trick them into clicking on the simulated phishing campaign, and I'm going to track that, right? So let me design one here real quick. So I'm going to launch this attack, right? I'm just going to call it a test demo attack. I'm going to use a template. I don't have to. I can come up and design it however I'd like, but I'm going to call it a payroll update, right? Just from our template, I'll hit next, right? Who do I want to attack? Well, I'm going to attack Megan, and I'm going to attack. Let's see who comes up. Oops, there we go. Adam. You could put multiple names in here. We'll just do the 3 for right now. I'll click on next, right? There's my subject. Here's what the phishing email will look like. You can look at the HTML, the source code for this, which is HTML in the background. We can click on next. You can edit that text however you like. And then finally, I'm prompted, hey, do you want to proceed? Well, sure, let's attack our users.
Large licensing providers are great, but often you wind up just kind of taking orders, and you're not necessarily doing that kind of analysis of, do you need this license? How can we offer that? So we had a customer come to us, and this was kind of what their licensing looked like as we started out. Taking a glance at that, I can just tell you, for example, that Azure Advanced Threat Protection is a license that is included. It's one of the add-ons to Enterprise Mobility and Security E5. So there's almost $3,000 being spent that doesn't need to be. It's already part of their license subscription.
Every month.
Every single month, right? That's not an annual. That's not a one-time. That is an every month cost that isn't necessary. The other thing, you look at some of these. If you were to look at, say, Skype for Business Online Plan 2, looking at this Power User and Power BI Pro, that's $16. Plus the Office 365 E3 user is $20. There's $36. All of those are included in the Office 365 E5 user, which is $35. So it's only $1 a user a month, but $1 a user a month does add up. So being able to kind of walk through this with our customer, we were able to offer some options on how to change and save a pretty decent amount of money every month.
Do this with website attack vectors, which is 2. then I want to do a credential harvesting attack. Just 3. And I'm going to do a site cloning. Just 2. All right, so the idea behind this is I'm going to replicate or clone a live website, and theoretically what you could do is send the link to your Kali Linux box to a target. They would click on the link, enter their credentials, and you would be able to capture their credentials. So let's see what that actually looks like. So what this says is, where do you want the information to go back to during the course of this attack? So the IP address for my machine, it says 10.0.16.4, so let's try that, but that's not the same as the one that was showing on the Azure portal, so this may not work. We'll try it though. And then what is the website that I want to clone? So I'm going to try Facebook. Okay, so just for comparison's sake, what I'm going to do is open up Facebook so you can see what the actual Facebook page looks like today. All right, so I'm going to replicate that web page. So I type in http www.facebook.com, hit enter. There's this instruction that says you might need to copy these files into a different location, and if you just say yes. All right, so now it's ready to go. So now essentially what's being said here is the Facebook page is now being replicated back to 10.0.0.16.4. Now what I want to do real quick is just confirm that that is my actual IP address before I go further. 10.0.0.16.4. Okay, so I'm good. So now what I want to do is go back to the web page. Remember, this is the actual Facebook. Now let's do a local instance of 10.0.16.4 and port 80. Now, if this is working correctly, what this should show me is a local instance of the Facebook page. And there it is. It shows me it's not identical, but it's using the same forms-based authentication, and to a casual user, it would look the same. So I'm going to put a fake address in here and a very, very secure password and log in. Now, what's interesting, when I logged in, it didn't let me log in, but it did take me back to the real Facebook page. So a user who might then start to look at the page would then see, oh, okay, I was logged into the right place. I'll try to log in, and then when they log in that time, it'll work. But let's see what's happening on the other end. So my Kali Linux box has captured some information. Okay, so it has captured my login attempt. And now what I'm going to do is, as it says here, hit Control-C to generate a report. So I will hit Control-C. And notice it says that there is a file that has been exported to root SET reports. So that's where I'm going to go. All right, so I go to my file system. I go to root.set. All right, and 12/6, that's today's date. So this should be the report of what happened with this attack. So here's the report generator. And if I go down through here, what it says is log into facebook.com. It gives me a bunch of information about what happened during that the connection there. But the important part is down here somewhere. Showing me mouse movements. And here we go. So here is where it captured my username and password. So if this had been a real attack, I would now have login credentials for the user that I was attacking. Very, very easy attack to set up, very easy attack to implement.
So let's take a look here. I've gone ahead and created an entry called Project Aurora, which is just a sample information protection label that we've created for the purposes of an internal project. We could say this is a mergers and acquisition. So you'll notice that you have a bunch of options that you can come in here and set on the policy. So we can set so from a protection perspective, when you're gonna set the actual encryption on the files, you have a variety of different things you can do here. So you can use an Azure-based cloud key, or if you have an organization that wants to bring their own keys into the environment to make sure that they own the root of authority for all of the security that's going to be taking place on files, you have the ability to use hold your own key or bring your own key into Azure and use that as well. You can control some content expiration, so you can basically time this data out. So for example, if you are submitting requests for proposals or RFPs, or responding to RFPs, or putting out budgetary estimates, or providing something that's going to have a 30-day window, you can come in here and set content expiration based on these, so that after a period of time, that material is no longer viewable based on whether or not that material is expired. You can also allow offline access, and this basically allows you to prevent people from being able to do something with the file and internet connection. And so, a couple of good examples here would be if you have somebody who may have a need for that data while they're on an airplane flight, you can come in here and you can set the amount of time that you can allow this data to be viewed without an internet connection. And so you can strike a balance between the protection of the data as well as the ability of the person to use that document in disconnected states and manage that with the data loss concerns of the organization. Now, additionally, we can set some visual markings on this data for when these policies get applied. And here we can see that you can set headers and footers on the files, as well as you can set a watermark on the file, which is listed here. And you can set the color and the font and so forth on these. And then you can configure some conditions about when this policy might automatically apply to a set of data. So in this case, I've created a policy called Aurora, and anytime the term Aurora appears in a document more than 2 times, this label will automatically be applied to any file that contains that word.
Right now you can see under tables, if I were to run anything from this query from systables, you can see nothing's in there right now at this point. Okay, so what I'm going to do now is I'm going to go over to the virtual machine that's housing my SQL Server. What I did is I put the migration assistant right on my SQL Server just for this demo. Again, in the production instance, is probably not something you would want to do. You never want to pollute your production servers with anything. But I did it. Okay, and so in the assessment, we selected some data sources. In the interest of time and typos and demo problems, I just already plugged into my SQL Server, which is right here, and I ran a assessment. They're very easy to do. You just come through here, select your data source, and you just run your assessment, and up it comes. And you can see right here in my assessment, right here, it comes up with some recommendations talking about things to do with reporting services, and another thing having to do with trace flags. Again, nothing that would be alarming or would be a showstopper in a migration. And for compatibility issues, it came up with none. So there's just absolutely nothing. So it looked for 140 different use cases for compatibility here and found 0, and 30 here, it found 0. And so just absolutely no compatibility issues. Okay, and then over on this side, again, the way this works is that you select your data sources, and this would be your source, which would be your SQL Server, and your target, which would be your Azure SQL database. I've already done that. You can see them right here. My source database is my demo DB, and it's sitting on this SQL Server. My target database is this Azure database you see right here. And so I've already pre-filled those just to get around typos and things. So right now what we're doing is we're selecting the objects that we'd like to migrate. And I've created a couple tables out there which I have pre-populated with on my SQL database, which I pre-populated with public domain medical disease information, just to get a lot of rows and diverse columns and things like that. And that way, you know, would show the compatibility that most of the time, if it's running successfully on your SQL Server, it's going to run successfully in Azure, unless you've done something a little funny or obscure. Okay, and so what we'll do now is we'll click this button here and we'll say Generate SQL Script. And it creates a SQL script that would actually create your schema in your Azure in Azure SQL. And as you know, when I just went over to when I showed you the Azure SQL database, there was no tables in it, and no tables, no rows. And so let's just say deploy schema. Just like that, it ran. And I'm going to now minimize this, and remember over here where I showed nothing, I'm going to refresh this, and oh, look, here they are.
And what this allows me to do is have visibility to those third-party cloud apps. So in my environment here, we're using Box, we're using G Suite, we're using Salesforce and Office 365. But if I go to this tool here and I click on Activity Log, I can see activity for these different cloud apps. So here I can see activity for Salesforce and G Suite, and Box is in here as well. I can see when people sign in. I can see when people try to create a file, when they try to maybe add permissions to that file. One of the common challenges I often hear from customers of ours is that we may have files in, say, Google Drive, but when you go to share that file externally with somebody outside of Google Drive, there's no way for us to keep track of that. So we actually have no idea who has access to our data. Well, this will tell you. So here I could see where different files have been shared. I could just have all sorts of visibility on what's happening across these cloud services, these non-Microsoft cloud services.
So what I've got here is I've already loaded up a day's worth of logs from, again, a fictitious environment from a Sonic wall, right? We can support not just Sonic walls, but about at least 20 different flavors of firewalls, from the Ciscos to the Palo Altos to the WatchGuards, and even though those that aren't listed, there's a custom log format that we can try to import as well, and we can manipulate logs as needed to match the import process. So a day's worth of logs for a small to medium-sized business takes a couple hours to parse through, and as a result, you get a dashboard similar to this, right? Where we've got, as I look at this, we actually have cataloged quite a bit of information on about 16,000 applications out there in the cloud, and I'll run through that here in just a few moments. But this is, based on that catalog, that's where this data is coming from. So we can look at this and say, okay, of those logs, there's 293 applications that have been found, across just over 2,100 IP addresses by 457 users, and so on and so on. But that's all great. But what I always zoom in on when I look for shadow IT, I want to see where the dangers are. Right, so as I look at this, let me click on this here. As I look at the map down below, we've got information on IP addresses and where data is coming to, or coming from or going to, right? So we can see here, okay, this is a US-based business, but let's say, for example, it's a small medical facility within the US, right? It serves a regional area somewhere in the Midwest. They're in Iowa somewhere, right? So in here, we can say, okay, I've got 239 instances, apps in the US, but I've also got all these other apps here. I've got one going to Ireland, 12 to the UK, one to Poland, Israel, Egypt, India, and then I get to China, or Russia, and I say, I'm a small business over here. I don't think I should have any traffic going here, but let me see what that is. So I'm just going to click on this dot here. And again, this is my data just being presented back to me in a different way. But I look at this and I say, I did have this antivirus client around. I thought I got rid of all of these instances. I moved over to Symantec or Windows Defender or something like that. Why is that still here? Okay, so I'm going to click on that. I don't know much about it, for example, but I do. Most of us do here. We recognize the name. Okay, it's headquarters in Russia. It's been patched for the Heartbleed. It's got a valid cert on it. Does not support SAML, but look at the compliance categories. It's not ITAR, it's not SOX, it's not Safe Harbor. There's GDPR in here now as well, with that being a very hot topic, right? So that's interesting. But let's go back here for a moment. And what else do I have? Instead of looking at the map, right, I can now look at I can look at all of the apps, all 457 of them in here. Actually, I'm sorry, 293. And I look at these and I say, each one is scored. Well, the score is great. I see 10s down here. It's on a scale of 0 to 10, 10 being the most trusted. We've got Microsoft apps in here. We've got Cisco, IBM, it's Concur, Travel App, Adobe, and the normal players, the big players on the web. You look at this and you say, okay, well, I want to look at this a different way. My risk score of 0 to 10, I want to scope this down. I want to get down to the 0 to 3. Again, what's interesting? What should I be more concerned with in my environment that I don't know about that someone has installed here? I'll wait for that to filter through. And up comes a couple of apps that I may not have ever heard of. Well, on these apps that I haven't heard of, I can click on each one as soon as it comes up here. Yep, we'll come back to that. Not sure why it's not loading up there. But I could click on each one and I could get to each one of those categories that are in there. Is it GDPR compliant? Does it have the Heartbleed patch to it, and so on and so on? But here's a couple that came up here in the screen. Okay, so Copper Egg, I had not heard of them before. What is it? Well, it's got a score of 4 overall, 5 in the general, 8 in the security area, but 0 in compliance. Again, going back to my example, I'm a medical facility. I must be concerned with HIPAA regulations, right? I've got something in here that could be, provide the potential for a data breach, right? So I've got to go in here and look at that and say, let's find out who's using that. Let's see where that is. So I click on the name, right? And I find I've got 18 active users. Why? Is this an infection? Is it malware masked as something else, right? Where is it, right? So the users will populate here in just a moment. Again, there's a lot of data to parse through. And then I know I've got it on 13 different IP addresses, right? There's not much traffic going up. So, okay, I'm somewhat satisfied on that, but let's go ahead and let's look at it still, even on that. Who are my users? Because this is an Office 365 integrated application, I know who these users are, right? I can go right down and now I can create a list and go out and visit each one of these people and figure out, okay, did you put this on here? Or is it some type of a drive-by infection that I need to now be concerned about?